So this is section 7.5, and we are solving equations with rational expressions. So that means all of the fraction rules that we've been talking about, we've got to carry those over. We have to carry those over into this part. Here, solving equations containing a rational expression. To solve equations containing rational expressions, clear the fractions by multiplying both sides of the equation by the LCD. Okay, so we're still working with the LCD. That means we are still going to be working with factoring. Factoring is going to play a key role. Then solve the simplified equation as we've done in the past. There is an important part that we've got to think about when we're solving equations with rational expressions, and that is our excluded values. That is going to play a key role. We have to check our excluded values. And when we're dealing with rational expressions, we have to have a value that does not make the denominator 0. Okay? So we've got to remember that I can't have 0 in a rational equation. Check excluded values. We have to be sure that we check excluded values. Okay. You cannot have a 0 in the denominator. And so we've got to make sure that our answer does not give us 0 in the denominator. And if it does, we have to throw that answer out. So we're always going to have to go back and say, okay, what are my excluded values? So we're going to check excluded values. And here are our steps to solve these. Step 1, multiply both sides of the equation by the LCD of all rational expressions in the equation. Okay? So we're going to find the LCD, and then we're just going to multiply everything in that equation by the LCD. Step 2, remove any grouping symbols and solve the resulting equation. Step 3, and this is very important. Step 3, check the solution in the original equation, and specifically what we're checking here for is excluded values. Okay, and an excluded value is going to be what makes the denominator 0. So that's our last part, is we've got to make sure what we get for the answer does not make the denominator 0. Okay. Now, to start with, we are just going to look at a few that are fractions, that they don't have any variables in the denominator, just to remind ourselves how we do those problems. Okay? So here's the first one that we're going to look at. I've got x over 4 plus 4 over 5 equals 1 over 20. So what I'm going to look at, I'm just looking at the denominators. I have no variables in the denominator, so I need to find my LCD. What is my LCD between 4, 5, and 20? It's 20. Okay, that's the LCD. So what I'm going to do is I'm going to multiply everything by 20. Now, are there any excluded values in this problem? There's not. There are no excluded values in this problem because we do not have any variables in the denominator. Okay, so the answer to this could be anything. There's nothing that would make this undefined because there's no variables in the denominator. Okay, so I'm going to write off to the side no excluded values. Okay, no excluded values. So I'm going to multiply 20 over 1 times x over 4 plus 20 over 1 times 4/5. And that's going to equal 20 over 1 times 1/20. So all I've done, here's my original problem in purple. Okay, and I multiplied everything by 20 because that's my LCD. Okay. Now this part right here makes this a much simpler problem to solve. So what I'm going to do is I'm going to start canceling. So my 4 and my 20 can be simplified. Okay. My 5 and my 20 can be simplified. Okay. So right here, what am I left with? 5x. And right here, I have 4 times 4. What's that? Okay. And then here, I'm left with 1. Okay. And do we know how to solve this equation? We do. We subtract 16 from both sides. Okay. And then I have 5x equals negative 16. Or negative 15, I'm sorry. I divide both sides by 5, and I get x equals negative 3. Now, our last step is that we've got to check to make sure this does not give me something that's undefined. So all I really have to do is I have to look at this negative 3 and compare it to my denominators. If I plug negative 3 into this, is this going to give me 0 in my denominator? Is negative 3 an excluded value? It is not. Okay, so I'm good. Negative 3 is my final answer. It's checking for that excluded value that you want to make sure that you do. Okay. Now, the next one is similar because we do not have any variables in the denominator. So look at this denominator. I've got a 3, a 5, and a 15 in this denominator. Are there any excluded values? Is there anything that this cannot be? Is there anything this cannot be? No. Okay, I do not have a variable in the denominator, so there are no excluded values. No excluded values.
So the only time when it would be an excluded variable is when we have a variable in the denominator.
Correct. Correct. That's when we have to think about our excluded values. Okay? And then what would happen then is if our solution or our answer came out to be that number that was an excluded value, we have to throw it out. We have to throw it out. Okay, there's something else here that might confuse us. Anybody know what it is? The negative. Okay, we got to be careful with that negative. Now, I am going to change that to a plus, and then I am going to move that negative to the numerator. But you got to be careful there, because that negative belongs to the entire numerator. Now, if you wanted to go ahead and distribute that right now, that's fine. Okay, I'm going to hang tight. I'm going to leave it like that with the negative 1. But you could go ahead and distribute that if you wanted to. Okay, now let's look at our LCD. So I've got a 3, a 5, and a 15. What's my LCD? 15. So I am going to multiply everything times 15 over 1. So I have 15 over 1 times x plus 2 over 3. Then I've got 15 over 1 times negative 1 times x minus 1. You could have distributed that already if you wanted to. That would have been okay. And then I've got 15 over 1 times 1 over 15. And again, just like with those complex fractions, I encourage you to pause. Make sure in purple that you've got your original problem written down. And then in red, I am multiplying everything by my LCD. And now, I'm going to cancel what I can. 3 goes into 3 one time, and 3 goes into 15 how many? 5. What am I going to have to do with that 5? Distribute. Good. Okay, 5 goes into 5 one time, goes into 15 how many? 3. What am I going to be distributing there? Negative what? Negative 3. Good. Okay, so I've got 3 times negative 1 And so I'm actually distributing -3 right there. That's what I'm distributing. Okay? And then 15 and 15 cancel. Okay, and I'm going to write this out. I'm not going to distribute yet. So here I've got 5 times x plus 2. Okay. And right here, I've got 3 times -1. So that's what I have to distribute. So I'm writing this down as -3. And I've accounted for my 3 and I've accounted for my negative right there. Okay, and what's this equal to? 1. Okay, and now do we know how to solve this? We do. So I'm going to say 5x plus 10 minus 3x plus 3. Okay, don't forget you've got to distribute that negative. Oh, it looks like I'm left with 2x plus 13. Okay. I subtract 13 from both sides. And I'm left with 2x equals -12. Divide by 2, and what's my final answer? -6. Now, I have to ask myself, is this -6 an excluded value? And it is not, because I have no excluded values. No excluded values here. Okay. Can I go to the next one? We do have excluded values here. So that's what I want to ask ourselves first. What are my excluded values? The reason I know I have excluded values is because I have a variable in the denominator. That's how I know I have excluded values, is because of that variable in the denominator. Okay? That's how I know. So I've got to take that denominator and I've got to set it equal to 0. So what is it that x cannot be? 0. Good. X cannot be 0. You're correct. So my excluded value for this is 0. Now, I've got plus 1. What can I write that 1 over? Good. Okay. So now, I'm going to rewrite this, and I'm going to have 5 over 3x plus 1 over 1, and I'm going to go ahead and write that 6 as a product of two numbers. What can 6 break down to? 2 and 3. Okay? And that's helpful when you're trying to find your LCD. So I've got to make sure both of these are included in my LCD, so that's going to be 3 times x. Okay, then I look here. I've already got a 3. What do I not have? 2. Okay. Okay, so my LCD is going to be 2 times 3 times x. I typically leave it in factored form because I know I'm going to be canceling some of these out. Okay, so I have 2 times 3 times x over 1 times 5 over 3x plus 2 times 3 times x over 1 times 1 over 1, 2 times 3 times x over 1 times 7 over 2 times 3. Okay, take a minute, pause, ask yourself, do I have in purple my original problem? Do I have in red my LCD? Pausing there is always good for you to see where you're at. So here I've got a 3x in the denominator. So I am left with 2 times 5. Okay. Here, nothing cancels because this is over 1. So I'm left with 2 times 3 times x. So that is 6x. Okay. Here my 2's cancel and my 3's cancel, and what am I left with? 7x. So I've got 7 times x. Okay. So now I'm going to subtract 6x from both sides. And I'm left with 10 equals x. Okay, now I've got to ask myself, is this an excluded value? Is it an excluded value? It is not an excluded value. Okay, so I am good right here. Okay, the next one's a little bit more complex. Okay, I see a couple people writing, so I'm just going to pause for just a second while people are writing. Okay. Okay, now for our next one, we've got a whole bunch of stuff going on in this one. Whole bunch of stuff. When you don't know where to start, it's always a good idea to factor. Okay? If you're not really sure where to start, we'll factor. Because breaking things down helps us to see what we need to do next. Okay? Now, our first one, I've got a 2x right there, so I can't really factor that. That's just 2 times x. Okay? As I'm doing a rewrite, I see this minus right here. I want to go ahead, change that to a plus, and move that to the numerator. So then I'm going to have plus -1. This cannot factor. X plus 1 can't factor. Okay? So then I've got x plus 1. Okay? Now, this does factor. I can take a GCF out of that. What does that factor to? 3x, and then I'm left with what? X plus 1. Excellent. Okay, now this is a little bit more manageable. A little bit more manageable. So I've got a couple of things that I've got to throw out. I've got some excluded values that I need to go ahead and think about. Okay? So I'm going to figure out what those excluded values are. I always like to have my excluded values written off to the side. Excluded values, because I always need to compare my final answer to those excluded values. Okay? So right here, I've got a 2x. So that 2x cannot be 0. So what is it that x cannot be?
0.
Can't be 0. Good. Okay? Here I've got another x right here, x plus 1. So my x plus 1 cannot be 0. So what is it that x cannot be? -1. Okay, I've got one more denominator that I need to worry about. If I were to put 3x equal to 0, okay, what would I get for that one? If 3x cannot equal 0, what can x not be? 0. So I've already accounted for that one. Then I've got x plus 1, and look, I've already done that one. Okay, so really I just have 2 excluded values. My 2 excluded values are 0 and -1. That means if I get either one of those as an answer to this problem, I have to throw them out. I have to throw them out. Okay, so now I want to find my LCD. I'm going to look for my LCD. So I'm going to go right here. I've got a 2 and an x. So I'm going to have 2 times x. This x is different than this x because it's in a binomial. I've got to include that entire binomial as part of my LCD. So that's going to be x plus 1. I've got the x covered in this last one, and I've got the x plus 1 covered. What do I not have covered? The 3. Okay. So now I am going to multiply everything times 3 times 2 times x plus 1. I would not multiply that out. I would keep it. I mean, you could do 3 times 2 is 6 if you wanted to. I typically don't because I know I'm going to have some stuff to cancel out. Okay? So I'm going to multiply everything times my LCD over 1. Okay? And this gets long. This gets long. And that's okay. But go ahead and write this step out. So I have 3 times 2 times x plus 1. That's over 1, and I am multiplying that times 1 over 2x. Okay? I'm going to do it again. Don't skip these steps. You want to write them out. 3 times 2 times x plus 1 over 1 times negative 1 over x plus 1. Okay, don't lose that negative. That's why we go ahead and write it in that denominator right there. Okay, then I've got 3 times 2 times x plus 1 over 1 times 1 over 3x, x plus 1. Take a minute to pause. Take a minute to pause. Is everything in red my LCD over 1? And is everything in purple my original equation? Okay, you just want to pause here to make sure you didn't make any mistakes. Now we're able to cancel out. Here I've got a 2 and I've got an x that can cancel. So now I'm going to write down 3 times x plus 1 times 1. So I don't have to write down that 1 again. Okay? Here, my x plus 1 and x plus 1 cancel. So here I've got 3 times 2 times x times negative 1. What is 3 times 2 times x times negative 1? Negative 6x. Good job. Okay, then I've got 3 and x that cancel, and then I've got x plus 1 and x plus 1 that cancel. So then what am I left with? 2. Okay, and do we know how to solve this equation right here? Okay, we do. We just distribute. Okay, so we distribute the 3x plus 3. Then I've got minus 6x equals 2. Okay, 3x and negative 6x is negative 3x. Okay, then I'm going to subtract 3 from both sides. When I subtract 3 from both sides, what do I get? Negative 1. I divide by negative 3, and so x is positive 1/3. Positive 1/3. Okay, now, don't forget, what do I have to do? Excluded values. So I take my 1/3, I go back and look at my excluded values, and am I okay? Good. You are okay. 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 Now, this one right here. This is different than some of the others that we've done. This is one rational expression set equal to another rational expression. We do not have multiple rational expressions on both sides. Does anyone know how we could solve this? Does anybody know what it's called? It's when we have proportions, how we could solve this. Okay, does anybody remember cross multiplication? Cross multiplication. You could solve this using cross multiplication. The only reason you can solve this with cross multiplication is because you have a single rational expression equal to another single rational expression. That's the only reason. When you've got multiple rational expressions on one side, you cannot use cross multiplication. But here you could if you wanted to. Okay, so what I would do with cross multiplication is I multiply these two together, and then I multiply these two together. Okay, so I would have 1 times x plus 2, or I'm sorry, x plus 1. Okay, so I've just multiplied 1 times this, and that's equal to 2 times x minus 1. This only works because I have a single rational expression on each side. If you do not have that, you cannot use this method. Okay? And then I've got x plus 1. I need to distribute my 2. Okay? What I'm going to do is I'm going to go ahead and take this x and move it over here. Okay? And that's just because then I keep my x positive. It would be fine if you subtracted 2x from both sides. There's nothing wrong with that, subtracting 2x from both sides. I'm going to go ahead and subtract x because then I have a positive x on the right-hand side. So then I've got 1 equals 1x minus 2. I add 2 to both sides, and I get that 3 equals x. Now, we did not talk about excluded values on this one. Okay, so I need to think about excluded values. Just because I can use cross multiplication here does not mean I don't need to think about excluded values. So I've got 2 different denominators. Both of them have a variable in them. So I need to figure out excluded values for both of them. So I have x minus 1 cannot be 0, and I have x plus 1 cannot be 0. Okay? So what is it that x cannot be? Good. X cannot be 1, and x cannot be negative 1. Okay? Now, am I good with x equals 3? I am. Now, I can solve this the exact same way, multiplying everything by the LCD. So I've got 1 over x minus 1 equals 2 over x plus 2, or x plus 1. Okay, what's my LCD here? Good, x plus 1 and x minus 1 is my LCD. Okay, so I could multiply both sides times that over 1, and I'm going to get to exactly the same place that I was. And I just want to make sure you understand the only reason that I could use cross multiplication here is because it was a single rational number expression equal to another rational expression. So now I can cancel, and I'm left with x plus 1. I can cancel here, and I'm left with 2 times x minus 1. Okay, and then we just solved that equation. So you're going to get to the same place regardless of which method you use. Okay, you'll get to the same spot either way. Okay. Okay, now I'm going to let you look at a problem, and I want you to do 2 things for me. I want you to factor it, and I want you to determine the excluded values. Okay, so you're going to factor it, and you're going to figure out the excluded values. Okay. Okay, so right here what I want you to do is I want you to factor the denominators, and then I want want you to determine the excluded values. That's what you're doing right now. Okay, so I asked you to do two things. I asked you to factor the denominators. So let's do that. So I've got 12 over 3 plus a and 3 minus a. That looks a little different, but it's still the difference of perfect squares. It's still the difference of perfect squares. Then I've got 3 over 3 plus a. And then I have 2 over 3 minus a. Okay, so I only had to factor that first one. I only had to factor this one right here. Okay, now I need to talk about excluded values. So none of my denominators can equal 0. So the first thing that I'm going to do is I'm going to deal with these two right here. So I'm going to have, for excluded values, okay, excluded values, I'm going to have 3 plus a cannot be 0, and then I'm going to have 3 minus a cannot be 0. Okay, so I subtract 3 from both sides, and I get that a cannot be -3. Okay. Here, what I'm going to do for this one is I'm actually just going to add a to both sides to solve that one. I'm just going to add the a to both sides. And so then I get that 3 cannot be a. So what are my two excluded values? 3 and -3. So if I get 3 or -3 as my answer, I got to throw it out. I can't use that because that would make these denominators undefined. Okay, so I'm looking for a 3 or -3. Now let's talk about my LCD. My LCD. First thing I'm going to do is I'm going to make sure both 3 plus a and 3 minus a is part of my LCD, and that's covered right here. Okay, so I've got 3 plus a and 3 minus a. Okay, do I have this one covered already? I do, so I don't have to write it down again. And do I have this one covered? I do, so I don't have to write it down again. Okay, so now I'm going to multiply everything times 3 plus a, 3 minus a. Okay, so 3 plus a times 3 minus a over 1 times 12 over 3 plus a, 3 minus a, 3 plus a, 3 minus a over 1 times 3 over 3 plus a equals 3 plus a over times 3 minus a over 1 times 2 over 3 minus a. Okay, don't skip these steps. Look to make sure everything in red is your LCD. Make sure everything in purple is part of your original problem. And now we can cancel. So I've got 3 plus A and 3 minus A. So I'm left with 12 right here. Okay. 3 plus A and 3 plus A cancel. I have to distribute that 3. So this is going to be 3 times 3 minus A. Okay. Then I've got 3 minus A and 3 minus A. So I'm going to have equals 2 times 3 plus A. Okay. Do we know how to solve this? We do. We know how to solve this. Okay, so let's distribute our 3. So I've got 12 plus 3 times 3 is 9 minus 3A. Okay. Then I've got 2 times 3 is 6. 2 times A is 2A. 12 plus 9 is 21. Okay. Let's go ahead and add 3A to both sides. Why did I add 3A to both sides instead of subtract 2A? Keeps the variable positive, okay? Then I'm going to go ahead and subtract 6 from both sides. So now I've got 15 equals 5A. Okay, so 15 equals 5A. I'm going to divide both sides by 5. And I get that 3 equals A. Now, a lot of people stop right there. They do all this work, they do all of their calculations correct, and they do a great job, and they forgot to do one thing. What did they forget to do? Excluded values. 3 is an excluded value. That means I have to throw it out. I have to throw the A out. I cannot use it. So what that means is the final answer to this is no solution. No solution. No solution. Okay? And so your next slide says, as we can see, it's important to check the proposed solution to the original equation. And the original equation provides for us the excluded values.